Howdy, howdy. This is Mr. Potter. In our previous lessons, we've talked a lot about how to deal with loops. Loops are basically whenever we want to execute code multiple times in a row, such as when we were doing the linear search or when we were doing all the sorting algorithms in the previous unit. So what's really important to notice is that, let's just say I write a real quick loop here. So for int I gets 0, I is less than 3, I plus plus. A loop really has three parts. You have your initialization. In other words, I have to start my loop control variable at some point. And then I have my test. There has to be something that checks to see how long I'm going to keep doing this loop. Or something that determines when I'm going to stop the loop. And then I have to have my iteration. And the iteration just basically says, how am I going to get closer to my base case, the case where I'm going to stop looping. So all loops have to have these three parts to it. Some initialization, some starting case that we're always starting with, some tests that keep saying, let's keep going until this happens, or as long as this is true. And then an iteration, which allows us to get closer and closer to that test case. All loops have these three parts. And for a for loop, they're really easy to see because the first one has to come before the semicolon. That my initialization always has to go here. My test always has to go in between the two semicolons. And the iteration has to go at the end between the last semicolon and the close brace. And so what happens is anything that's between these braces is going to get repeated, in this case, 3 times. Once when I is 0, a second time when I is 1, and a third time when I is 2. Then as soon as I hits 3, we stop. So those are our three parts. But what I want to talk about is I want to talk about two other loops that we deal with. And so what I'm going to do is I'm going to create another method down here. I'm going to call this method public static int, and this is going to be just a method called log estimate. And I'm going to have an int value and an int base. And what this is going to do is it's going to estimate the logarithm of the value in the given base. So what I'm going to do is I'm going to keep doing this. I'm going to figure out what the logarithm is. In other words, what power I'm going to have to raise this to in order to raise the base to this power in order to reach this number. And so I'm going to start off by saying, you know what, I'm going to start at 0. So int count gets 0. And this is our second loop. I want to run this as long as something is true. So this is going to be while val is greater than 1. And notice what I've got here is that I have a loop control variable, but my loop control variable is actually initialized here, because that's when I receive the value that I'm going to be using in my loop. My test is on a completely different line. And so I may use a while loop when I want to have this situation happen. I wouldn't want to put some type of initialization here because I really wouldn't want to change the value of this variable. And I don't think I'd want to leave this blank, because leaving it blank would make it very conspicuous. But what I can do is I can say, while the value is greater than 1, do the following code. And so we saw this with just a touch of this when we were doing our binary search, because it's hard to do a binary search using a for loop, because I'll end up with two different loop control variables, the low end and the high end, which get closer and closer to each other. And my test actually involves both of them, and my iteration actually involves changes to both of them. So in those situations where I don't know how long something's going to run, I just know it's going to run as long as some situation exists. That's where a while loop is actually going to be better than a for loop. A for loop is very well suited to when I know exactly how many times a loop is going to run. And that's usually when we use for loops, is when I want this loop to run 13 times, or I want this loop to run 22 times. But if I want this loop to run as long as something is this way, or as long as this Boolean expression is true, the while is actually the better way to go. This is more for your indeterminate loops, which may break very soon, or it may take a long time to determine. If you don't know how many times a loop is going to run, you should use a while loop. So what I'm going to do is I'm going to estimate the logarithm of this value given this space. So every time I go through this loop, I want to do two things. First thing I want to do is count plus plus. This is not my iteration, though, because my loop control variable is just value. And I need value to get to the situation where I'm getting down to 1. And what I'm going to do is I'm going to say val divide gets base. And this is actually my iteration. Because dividing by an integer over and over and over again, I'm eventually going to get down to 1, and then dividing 1 by that base is going to give me a 0. So this allows me, through the use of repeated division, to kind of estimate the logarithm. And so let me kind of just trace through real quick to tell you what's going on. Let's say I've got a value of 16 with a base of 2. So I'm going to start off count as 0. 16 is bigger than or equal to 1. So I'm going to count plus plus, and I'm going to divide by 2. So now 16 becomes 8. 8 is still positive, bigger than 1. So I'm going to count plus plus, now count as 2. And I'm going to divide by the base, so the 8 becomes 4. 4 is still bigger than 1, so I'm going to count plus plus. My count is now 3. And dividing the value by the base, 4 divided by 2 is 2. I'm going to count plus plus, so now count as 4. And 2 divided by 2 is 1. And then I'm going to break out of my loop because my value is greater than or equal to, actually I do want to just stop short at 1. And so at this point, count is keeping track of how many times 2 went into this value. I was able to divide it 4 times because 2 to the 4th is 16. So what I can do at this point is I can return count. And so what I've got here is I've got a loop that runs a little bit different than a for loop because I have no idea how big the number I'm going to get is. Maybe I'm going to have 9 and 3. Maybe I'll have 4 and 4. Or maybe I'll have 729 and 3. I have no idea what value or base I'm going to get. So I have no idea how many times this loop needs to run. So what I'm going to do is I'm going to set up a real quick prompting system. So system.out.print enter a base, and I'm going to in.next int, and I'm going to have that be base. I'm going to say int base gets int.next int. So I need my in to work, the standard input that we do. So standard input, we're going to need java.util.scanner. And first thing I want to do is I want to say scanner in gets new scanner system .n. And so what this does is now it's set up in as my scanning device, and next time I type in an integer, it'll put it in base. I'm going to do it again for the value, so system dot out dot print enter a value, and int value is in dot next int, and then I'm going to system dot out dot print line the log of value base is approximately, and then I'm going to return log estimate given value and base plus a period. So let's go ahead and run this, make sure I don't have too many errors. I need to import java.util.scanner. Always helpful when I do that. And I think I used val. It should be value. And value divide gets base. Just silly mistakes because I don't know how to type programs anymore. So enter a base. I'm going to say 81, and enter a value. I'm going to put 6,561, and it says the log of 6561 base 81 is approximately 2. So in other words, 81 squared is 6561. Now I'm going to enter a base 3. I'm going to enter a value 729, and it tells me that the base is approximately 6. In other words, 3 to the 6th power is about 729. Now I'm going to do another number. I'm going to do 10, and I'm going to do 2, and it's going to tell me the log of 2 base 10 is approximately 1. That's because dividing 2 by 10 gets me a number that's automatically less than 1, and so the program just kind of stops there. So it's an approximate logarithm system, but that's really all I'm doing here. I'm just kind of showing the purpose of this while loop here. So remember, all of our loops have to have an initialization, a test, and an iteration. A while loop does it in different parts. That's what makes it different from a for loop. And what also makes it different from a for loop is that it runs an indeterminate number of times. The number of times is determined by the test condition, but the test condition is not necessarily counting situation. So that's the first loop that I want to talk about, this while loop. There's one other loop that I want to kind of illustrate, and I want to talk about it in another method. I want to do one more loop here. I'm going to do it in a slightly different way, though. So I'm going to say public static Boolean check pin, and I'm going to say int master pin. And so what we're going to do is we're going to write a little method that's going to ask the user for a pin number and make sure that it happens a certain number of times. If they enter it correctly after, say, 3 tries, then we're going to go ahead and return true. If they don't enter it correctly within 3 tries, then we're going to return false. So I'm going to say int guesses gets 0, because they start off with 0 guesses. And then I'm going to use the word do. And I'll explain what this is in just a moment. So I've got this do, and I want to do the following. I want to prompt the user to type in a pin. So system.out.print, enter your 4-digit pin, and then I'm going to say int pin gets in dot next int, and then if pin is equal to master pin, in other words, if that statement is true, then I know that they've entered the correct pin, so I can just say return true. And then I'm going to say guesses plus plus, and that's going to be into this do statement, and I'm going to say while guesses is less than 3. Close parentheses and semicolon. And I want to kind of explain what's happening here. I'm starting off the number of guesses at 0. This is my initialization. And then my test is actually down here. I want to keep going as long as this is true. So this is my test. But what makes a do while loop different from the other loops is that it has to go through the motions at least once before it actually performs the test. In other words, this is what we call a post-test. The idea is that we're going to test it after we've completed at least one pass. Notice that if I typed in a value of 0, or if I typed in a value of 1 in this log program, it never would even enter this loop. If my initialization didn't make this test true, I would completely bypass this loop. But a do while loop has to be run at least once, which means it's going to ask the user at least one time for their PIN. And I can check to see if they typed it in, and if they're typed in their PIN correctly, then it's true. Otherwise, they get chance number 2. Otherwise, they get chance number 3. But if they make it through, and I've done this guesses plus 3 times, guesses have moved from 1 to 2 to 3. I break out of the loop. My iteration is still this guesses plus. This is my iteration. But if I made it out of the loop, then they didn't know the PIN, and so I'm going to return false. So what I've done is I've actually set this up so that it'll ask the user at least one time to enter in the PIN. It'll ask the user up to 3 times. But after 3 times, I'm going to say, nope, you just don't know your PIN. Sorry. Return false. So that's what makes a do while different from the other loops, is because of this post test. This test at the end, after I've gone through at least one iteration of the loop, I have to go through at least one iteration of the loop before I can hit this post test. And that's what makes a do while loop so much more special than the other 2 loops we talked about, since it's the while loop and the for loop. So I'm going to go ahead and change my main method to utilize this. So I've already done this enter a base, enter a value. That works. So what I'm going to do is I'm going to say Boolean pass gets check pin, and I'm going to say my pin is 1, 2, 3, 4. And I'm going to system.out. Actually, I'm going to if pass, then I want to system.out print line. You entered your PIN correctly. Else system.out print line. You didn't enter your PIN correctly. So I'm going to ask for the PIN 3 times to make sure everything works. Nope. That didn't work. What did it say? Cannot find the symbol. Cannot find in. Huh. go ahead and do this then. In, so scanner in gets new scanner system dot in. Just make sure it's declared there. Apparently, I had an issue with it not being declared in this method. We took care of that. So now it's going to enter my 4-digit PIN. I think my 4-digit PIN is 1, 2, 3, 4. Yay! I entered my PIN correctly. Now it's going to ask me a second time because our main loop has 3 iterations. Let's see. I think it's 9876. Nope. Is it 8765? No, maybe it's 7654. So I went through this and said you didn't enter your PIN correctly. Notice that it gave me 3 chances to enter my PIN. So let's see. I think my PIN is 1, 2, 3. Oops, I missed. I accidentally typed a 5 instead of a 4. I can't believe I'm such an idiot. Let me try this again. 1, 2, 3, 4. And you entered your PIN correctly. Notice that it keeps asking only as long as I haven't entered my PIN correctly. If I haven't entered my PIN correctly, I'm accruing these guesses. As soon as the guesses hits 3, boom, I've lost my chance. False is returned. I go on to the next line of code. As soon as I hit the PIN, though, as soon as I get that PIN correct, it returns true, and we go on with that. So, in addition to the for loop, which we use almost exclusively when we know exactly how many times we want to run a loop, we have 2 other loops that we've talked about today. We have our while loop, and we have our do while loop. Both of these can run an indeterminate number of times, and really both of these I could take a for loop and make it a while loop, or take a for loop and make it a do while loop. But the while loop is really much more situated to the situations where I don't know how many times a particular program is going to be run. And the do while is situated for those times when I know I want the program to run at least one time, possibly more than one time. And knowing which loop to do under which circumstances is one of the earmarks of a great programmer. So once again, this is Mr. Potter. Thank you for watching. Have a great day.